Then after we determine the number of triangle, then we can solve this triangle. So from the sine beta over b equal to sine alpha over a, you can first find the beta, right? So we first get the sine beta, which is equal to b times sine alpha over a. So this guy is equal to 9.8 times sine 75.3 degrees over 12.4, and then you simplify. Approximately you get 0.76. So now beta is equal to 49.86 degrees. Okay, we know this is the beta. Tell me, since we know sine beta equal to the 0.76, and you can have the two betas, two angles for which the sine is equal to 0.76. One is in the quadrant 1, another one is in the quadrant 2. Can this beta in the quadrant 2 bigger than the 90 degrees is an obtuse angle? Yes or no? You know this guy, this beta, actually here we just use the arc sine 0.76, right? But you also know sine of the pi minus the arc sine 0.76. This guy is equal to sine of arc sine 0.76, and this is equal to 0.76. Can beta equal to pi minus this arc sine 0.76? Yes or no? Why I just get this angle 49.86, and why I not take this pi minus the arc sine 0.76? You know, in a triangle, the angle opposite the short side must be smaller in the degree measure. And this A bigger than B, then alpha must be bigger than beta. So beta cannot be bigger than alpha. Alpha 75 degrees, then cannot be bigger than the 90 degrees. So beta cannot be an obtuse angle. So this is why we just take an acute angle for this beta. Okay? So now we got a beta, and then we can find the gamma. So gamma is equal to 180 degrees minus the sum of alpha and beta. So you plug in this alpha 75.3 degrees and this beta 49.86 degrees, then you get gamma. Gamma is equal to 54.84 degrees. And then you can find the length C. Okay, let's go to the next page. So from the C over sine gamma equal to A over sine alpha, you multiply both sides by sine gamma, you get a C equal to A times sine gamma over sine alpha. Then you plug in all these knowns into this expression. You have the 12.4 times sine 54.84 degrees divided by sine 75.3 degrees, and then you simplify, you have the 10.48. Done. Any question? Now let's look at one more example, and we'll deal with the most difficult and also the ambiguous case. So this is the SSA with two triangles. And let's look at the page 586, problem 12. And we know alpha is equal to 41.2 degrees, and A is equal to 8.1, and B is equal to 10.6. So let's draw the sketch. And this is alpha, and the vertex is A, and this is B, and this is the A. This point C, vertex C, and we can draw the attitude from C to this bottom line. Let me call this point B. So now let's first compare A with B. So definitely A is less than B, right? So A is less than B. Then we need to compare A with this H. Okay, so let's first get the H. H, that is the length of this attitude CD. So in this right triangle ACD, H is equal to B, the hypotenuse, times the sine alpha. So you have the B times sine alpha, and this is equal to 10.6 times sine 41.2 degrees, and this is approximately equal to 6.98. And after we find the H, let's compare this A with H. So A is equal to 8.1. So definitely this is greater than the length of this attitude H. So greater than the 6.98. Then we have the case that is the A is bigger than H, but less than B. We know in this case we have the two triangles, right? Now let's draw the sketch of this triangle. And this is A, So this is the B, and this is the B prime, and this is the C.